The Mandela Effect. Part 1. There are few experiences more unsettling than discovering that your memory disagrees with reality. Imagine finding an old childhood book and noticing that the title isn't quite what you remember. Perhaps you could have sworn a famous movie contained a particular line of dialogue, only to discover the words were never spoken. Maybe the logo of a company you've known your entire life suddenly appears different. At first, you assume you've simply forgotten. After all, memory is imperfect. But then something unexpected happens. You discover thousands, sometimes millions, of other people remember exactly the same thing. They remember the same movie quote, the same spelling, the same historical event, the same logo, the same scene. They describe it in remarkable detail. How can so many unrelated people remember something that never happened? This strange phenomenon has become known as the Mandela Effect. To some, it represents one of the most fascinating examples of how human memory works. To others, it is evidence that reality itself may not be as stable as we believe. Some suggest parallel universes. Others believe timelines have somehow merged. Some point toward quantum physics. Others even connect it to CERN and the Large Hadron Collider. The theories are as varied as they are extraordinary. But before exploring those possibilities, we need to begin with the story of how this mystery first entered public consciousness. Ironically, it all started with a funeral that never happened. The year was 2009. Author and paranormal researcher Fiona Broom attended a convention where she found herself discussing South African history with several strangers. During the conversation, she casually mentioned remembering Nelson Mandela dying in prison during the 1980s. To her surprise, everyone around the table agreed. Not only did they remember his death, they remembered television coverage, news reports, public mourning. Some recalled watching his funeral. Others remembered speeches delivered in his honor. There was just one problem. None of those memories matched reality. Nelson Mandela had not died in prison. He had been released from prison in 1990 after serving 27 years. Only 4 years later, he became South Africa's first democratically elected president. He remained an internationally respected statesman for decades. He finally passed away in December of 2013. Yet thousands of people sincerely remembered a completely different history. Broom later created a website discussing the phenomenon and coined the phrase Mandela Effect. At first, only a relatively small community paid attention. The topic seemed little more than an odd curiosity. Then social media changed everything. Within a few years, people around the world began comparing memories. The internet allowed millions of strangers to ask the same simple question. Do you remember this? The responses were astonishing. Example after example appeared. People insisted the children's books they had grown up reading were called the Berenstain Bears. Others confidently corrected them. No, they said. It was always the Berenstain Bears. People searched their bookshelves. Old libraries were examined. Original printings were photographed. Every authentic copy read Berenstain. Yet millions remained convinced they had grown up reading Berenstain. Why? No one could explain it. Then came another example. The Monopoly mascot. Most people picture the wealthy businessman wearing a top hat, a tuxedo, a cane, and a monocle. Except, he never wore one. Search original Monopoly boxes dating back decades. The monocle is absent. Still, ask enough people to describe him, and many will confidently include one. The same pattern appeared again and again. Movie quotes, television shows, corporate logos, brand names, geography, history, children's books, even Bible verses. Each example produced the same reaction. I know what I remember. That sentence would become one of the defining features of the Mandela Effect. The certainty itself fascinated psychologists. Memory researchers have long known that confidence and accuracy are not the same thing. People can vividly remember events that never occurred. Eyewitness testimony, despite its importance in criminal trials, has repeatedly proven vulnerable to error. Entire books have been written about mistaken memory. But the Mandela Effect seemed different. These weren't isolated mistakes. They were shared. Large numbers of unrelated people remembered the same incorrect information. That made the phenomenon feel much more mysterious. Human beings naturally assume that if thousands of people agree about something, it must contain at least a kernel of truth. Consensus feels convincing. Yet history reminds us that large groups have been mistaken many times before. For centuries, most people believed the Earth stood motionless at the center of the universe. They were wrong. Large numbers once believed diseases were caused by bad air rather than microorganisms. Again, they were wrong. Shared belief does not necessarily guarantee accuracy. Still, the Mandela Effect presented an unusual puzzle. Why were these particular memories so common? One explanation came from psychology. Another from neuroscience. Others came from quantum physics. Some ventured into philosophy. And still others entered the realm of science fiction. Before examining those theories, it is worth asking a more basic question. How reliable is memory in the first place? Most people imagine memory functioning like a video recording. An event occurs. The brain stores it. Years later, we simply replay the recording. Unfortunately, that is not how memory works. Modern neuroscience paints a far more surprising picture. Every time we remember something, the memory is reconstructed. It is not retrieved perfectly. It is rebuilt. Imagine reading an old handwritten letter. Each time you copy it by hand, tiny errors may creep in. A word changes. A sentence becomes shorter. Punctuation shifts. Now imagine repeating that process dozens of times. Eventually, the copy differs noticeably from the original. Memory behaves in a surprisingly similar way. Every recall slightly reshapes the memory itself. The next recollection uses the updated version rather than the original experience. Over months, years, or decades, those tiny alterations can accumulate. The brain also fills missing information automatically. It seeks patterns. It simplifies details. It blends similar experiences together. This process is usually helpful. Without it, everyday thinking would become impossibly slow. The brain constantly edits reality into manageable pieces. Most of the time, those edits go unnoticed. Occasionally, however, they produce remarkably convincing false memories. Scientists have demonstrated this repeatedly in laboratory experiments. Participants have become convinced they were once lost inside shopping malls as children. Others remembered shaking hands with famous cartoon characters. Some recalled witnessing news footage that never existed. The remarkable part is not merely that people believed these memories. It is how real those memories felt. Emotionally. Visually. Sometimes even physically. The brain often struggles to distinguish between a vivid false memory and a genuine one. That realization raises an uncomfortable possibility. Could at least some Mandela effects result from perfectly ordinary brain processes? Many psychologists believe so. Others argue that the phenomenon deserves further investigation. Meanwhile, outside academic circles, far more extraordinary explanations began appearing. What if the memories were accurate, but reality had changed? What if history itself had shifted? Could there be multiple universes? Could timelines merge? Could humanity somehow retain memories from another version of reality? These ideas captured public imagination almost immediately. Books appeared. Podcasts multiplied. Television documentaries explored the mystery. Thousands of YouTube channels began collecting examples. Some presented careful analysis. Others embraced increasingly dramatic theories. The Mandela Effect was no longer simply about memory. It had become a cultural phenomenon. A mystery discussed around dinner tables, in classrooms, across internet forums, and in documentaries watched by millions. Regardless of which explanation ultimately proves correct, or whether several explanations contribute, the Mandela Effect touches something deeply human. It challenges one of our most basic assumptions: that our memories represent an accurate record of the past. Once that assumption begins to crack, many other questions naturally follow. If memory can deceive us, how much of what we believe about our lives is truly accurate? And if memory alone cannot explain every reported case, could something even stranger be happening? Those questions would soon lead millions of people into one of the most fascinating and controversial mysteries of the modern world. End of Part 1. Part 2. Once the term Mandela Effect entered popular culture, people around the world began searching for examples. At first, there were only a handful. Then dozens appeared. Soon there were hundreds. Today, thousands of alleged Mandela effects circulate across the internet. Some are well documented. Others are based on misunderstandings. A few remain surprisingly difficult to explain. Whether viewed as evidence of faulty memory or something more mysterious, these examples have become part of modern folklore. One of the earliest, and still one of the most famous, involves a family of bears. For generations, children have learned to read with stories featuring Papa Bear, Mama Bear, Brother Bear, and Sister Bear. Millions of adults insist they clearly remember the books being titled The Berenstain Bears. The spelling seems natural. Many surnames end in Stein. It feels familiar. Yet every original book published by Stan and Jan Berenstain bears the same spelling. Brenstein. Berenstain. Libraries have original editions. Collectors own first printings. Publishing records confirm the spelling has never changed. Still, many readers remain absolutely convinced they once owned books spelling the name differently. The certainty itself has become part of the mystery. Then there is one of the world's most recognizable board games: Monopoly. Ask someone to picture rich Uncle Pennybags, the cheerful mascot. Most people immediately describe him: top hat, white mustache, black tuxedo, walking cane, and a monocle. Except he never had one. Original game boxes from the 1930s. Advertising posters. Television commercials. Modern editions. None show a monocle. Why, then, do so many people remember one? Psychologists suggest the brain naturally combines similar images. Characters representing wealthy businessmen often wear monocles. The mascot resembles figures from classic cartoons. The brain unconsciously completes the image. Yet for believers in the Mandela Effect, that explanation feels incomplete. Movie quotes provide another treasure trove of shared memories. Perhaps the most famous comes from Star Wars: The Empire Strikes Back. Nearly everyone recognizes the line, "Luke, I am your father." It has been quoted by comedians, television hosts, cartoons, commercials, children on playgrounds. It has become one of the most famous movie quotes in history. Except, that is not what Darth Vader actually says. In the film, the line is, "No, I am your father." The altered version became popular because it provides context. Outside the movie, simply saying "No, I am your father" makes little sense. Adding Luke's name instantly identifies the scene. Over time, the revised quote became more familiar than the original. Another classic example comes from Disney's Snow White and the Seven Dwarfs. Millions remember the evil queen standing before her enchanted mirror and declaring, "Mirror, mirror on the wall." Yet the original film begins differently. The queen says, "Magic mirror on the wall." Curiously, many later adaptations did use the phrase mirror, mirror. The famous wording existed, just not in Disney's original animated classic. Then there is Casablanca. People often quote Humphrey Bogart saying, "Play it again, Sam." The phrase has become inseparable from the film. Except, Bogart never says it. The closest line spoken is, "Play it, Sam." The familiar version entered popular culture through repeated misquotation until it eventually replaced the original in public memory. One fascinating example involves a monkey. Curious George. The lovable little monkey has entertained children since 1941. Ask people to picture him. Many confidently describe his long curling tail. Except, Curious George has never had one. Not in the original books. Not in television adaptations. Not in official artwork. The image simply feels incomplete without it. Again, our brains appear to add details that seem logical. Corporate logos generate equally intriguing discussions. Consider Kit Kat. Many people remember the chocolate bar's logo including a hyphen. Kit Kat. Yet official branding has always displayed the name without one. Kit Kat. Or think about Fruit of the Loom. A large number of people vividly remember the fruit emerging from a woven cornucopia. A horn-shaped basket associated with Thanksgiving. Current logos contain only fruit. No cornucopia. Collectors have searched vintage clothing, old advertisements, trademark records. No verified logo featuring a cornucopia has been found. Still, the memory persists. Some people insist they first learned the word cornucopia by asking their parents about the Fruit of the Loom logo. How could that memory exist if the basket never appeared? For psychologists, this represents an interesting puzzle. For believers, it suggests something far stranger. Then there are geographic Mandela effects. Some people insist New Zealand used to appear northeast of Australia. Maps consistently place it southeast. Others remember South America being farther west. Some claim the North Pole once contained a large permanent ice cap that no longer appears on modern maps. Again, historical maps generally fail to support these recollections. Still, countless individuals remain convinced geography itself has shifted. Perhaps no category generates more discussion than famous deaths. Besides Nelson Mandela himself, many people have reported remembering other celebrities dying years before they actually did. Occasionally, these memories result from confusion with another public figure. Sometimes an actor portrayed a dying character so convincingly that fiction blended with reality. In other cases, premature death rumors circulated online long before the individual actually passed away. The internet amplifies such misunderstandings with remarkable speed. Brand names also become subjects of debate. Many people remember Oscar Mayer being spelled Oscar Mayer. Others recall J.C. Penney lacking one of its letters. Some remember Febreze as Febreze. Others insist it was always Looney Tunes rather than Looney Tunes. Again, official records consistently support the current spellings. Yet millions remember something different. Why? One explanation involves familiarity. Our brains naturally favor spellings matching common language patterns. Stein appears more frequently than Stain. Toon seems logical for cartoons. Febreze resembles the word breeze. Without realizing it, the brain subtly edits unfamiliar words into more recognizable forms. Music provides another collection of famous examples. Ask someone to sing the opening line from Queen's "We Are the Champions." Many confidently finish with, "of the world." Yet listen carefully to the original recording. Those words are absent from the song's ending. Concert performances occasionally included the phrase, Radio edits differed. Public performances reinforced the mistaken memory until it became widespread. Another involves the song Lucy in the Sky with Diamonds. Many listeners believe the lyric says, "The girl with kaleidoscope eyes." It actually says, "The girl with kaleidoscope eyes." Here memory usually proves accurate. But in many songs, repeated radio exposure gradually alters remembered lyrics. This phenomenon has become so common it even has its own name. A mondegreen. A misunderstood lyric repeated often enough to become accepted. Religious texts have also entered Mandela Effect discussions. Certain Bible verses appear different to some readers than they remember. One of the best-known examples concerns Isaiah. Many people recall, "The lion shall lie down with the lamb." The actual verse refers to the wolf dwelling with the lamb. The lion appears elsewhere in related passages. Centuries of artwork and sermons often merge these images, creating a powerful but inaccurate collective memory. Perhaps one of the strangest aspects of the Mandela effect is not that people remember incorrectly. Everyone does. The mystery lies in how often the mistakes are identical. Why do unrelated individuals living in different countries remember the same altered versions? That question has fueled years of debate. Some researchers point toward language, television, advertising, shared culture. Repeated exposure gradually shapes collective memory. Others suggest that certain mistakes simply make more sense than reality. Our brains unconsciously simplify information. Logical errors become widespread because they are easier to remember than unusual facts. Still, these explanations do not satisfy everyone. For some people, the consistency of the memories feels too remarkable to dismiss. If millions remember the same thing, could they all really be mistaken? This question became the foundation upon which increasingly extraordinary theories were built. Parallel universes, timeline shifts, quantum mechanics, simulation theory. Some even suggested that humanity had unknowingly crossed from one reality into another. Whether any of those ideas contain truth remains unknown. But before exploring them, we first need to understand something even more fascinating: how human memory actually works. Because the greatest mystery surrounding the Mandela effect may not involve alternate realities at all. It may involve the extraordinary and surprisingly unreliable machine inside every human skull. The human brain. Part 3. If you were asked to describe your first day of school, your childhood bedroom, or your first bicycle, you would probably answer without hesitation. The memories might feel vivid. You may picture the colors, the sounds, the emotions, perhaps even the smell of the classroom or the feel of the handlebars beneath your hands. It would seem as though your brain had stored a perfect recording of the event. But modern neuroscience tells a very different story. Memory is not a video camera. It is not a hard drive. It is not a filing cabinet where experiences are carefully stored until they are needed again. Instead, memory is a living process. Every time you remember something, your brain rebuilds the experience from countless fragments scattered across different regions of the brain. This reconstruction usually feels seamless. So seamless, in fact, that most people never question it. Yet every reconstruction provides an opportunity for tiny changes to occur. Those changes are often so small they go unnoticed. Over years, or decades, they can become surprisingly significant. Scientists first began appreciating the fragile nature of memory during the 20th century. One of the pioneers was British psychologist Sir Frederick Bartlett. In 1932, Bartlett conducted a series of remarkable experiments. He asked participants to read unfamiliar stories and then recall them days, weeks, or months later. One famous story came from Indigenous Canadian folklore and was titled The War of the Ghosts. It contained unfamiliar names, unusual customs, and events unlike anything most participants had previously encountered. When people retold the story, something fascinating happened. Without realizing it, they changed it. Details disappeared. Names became more familiar. Strange elements were replaced with ordinary ones. Each retelling subtly transformed the narrative into something easier for the brain to understand. Bartlett concluded that memory is not passive. The brain actively reconstructs experiences according to existing knowledge and expectations. This idea revolutionized psychology. Later research confirmed it repeatedly. One of the most influential memory researchers of the modern era is psychologist Elizabeth Loftus. Her work demonstrated just how easily memories can be altered. In one famous experiment, volunteers watched videos of automobile accidents. Afterward, researchers asked questions using slightly different wording. Some participants were asked, "How fast were the cars going when they hit each other?" Others heard, "How fast were the cars going when they smashed into each other?" The difference seemed trivial. Yet participants who heard the word smashed consistently estimated higher speeds. Even more remarkable, a week later, many remembered seeing broken glass at the accident scene. There had been no broken glass. A single word had changed not only their interpretation, but their memory itself. Loftus conducted many similar studies. Again and again, she demonstrated that suggestion could create remarkably convincing false memories. Participants came to believe they had once been lost in shopping malls as children. Others remembered riding in hot air balloons. Some even recalled meeting fictional characters at amusement parks. These events never occurred. Yet the memories often felt completely genuine. The implication was profound. Confidence does not equal accuracy. Someone may sincerely believe a memory and still be mistaken. This finding has had enormous consequences for criminal investigations. For decades, eyewitness testimony was considered one of the strongest forms of evidence. Modern research paints a more complicated picture. Eyewitnesses frequently disagree. Lighting conditions matter. Stress affects recall. Questions asked by investigators influence later memories. Even seeing newspaper reports after an event can subtly reshape what witnesses believe they originally saw. None of this means eyewitnesses are dishonest. Quite the opposite. They usually report exactly what they believe to be true. The problem lies in the remarkable flexibility of human memory. Another fascinating process is called confabulation. The word sounds alarming, but confabulation is surprisingly common. It occurs when the brain unconsciously fills gaps in memory with invented information. Importantly, the person has no intention of deceiving anyone. The brain simply creates the most logical explanation available. Imagine waking from a dream. As details begin fading, your mind naturally fills missing pieces to create a coherent story. Memory often behaves in much the same way. This tendency helps explain many everyday experiences. Have you ever entered a room and forgotten why? Or confidently remembered placing your keys somewhere they never were? Perhaps you became certain someone told you something that they insist they never said. These minor errors occur constantly. Usually they have little consequence. The Mandela Effect, however, appears different because the same incorrect memories seem to appear across large groups of people. Psychologists suggest several reasons why this happens. One involves something known as schemas. A schema is the brain's mental shortcut for organizing information. For example, when you imagine a classroom, you probably picture desks, a teacher, students, a chalkboard or whiteboard. Even if someone describes a classroom lacking one of those features, your brain tends to insert the missing element automatically. Schemas make thinking efficient. Without them, every situation would require complete analysis from scratch. Yet schemas also produce predictable mistakes. The Monopoly Man illustrates this perfectly. He resembles wealthy businessmen from old cartoons. Many of those characters wore monocles. Your schema for rich gentlemen includes one. The brain quietly adds the missing accessory. Years later, the memory feels completely authentic. The same process occurs with movie quotes. Luke, I am your father identifies both speaker and listener. It makes perfect sense outside the context of the film. No, I am your father does not. The altered version is easier to remember. Over time, it becomes dominant. Language also influences memory. The human brain constantly searches for familiar patterns. Consider the names Berenstain and Berenstain. The ending stein appears frequently in surnames. Einstein, Goldstein, Bernstein. By comparison, Stein is relatively uncommon. Without realizing it, many readers automatically converted the unfamiliar spelling into a more familiar one. Repeated reading reinforced the mistake until it became a permanent memory. This process occurs far more often than most people realize. Memory is deeply influenced by expectation. There is another remarkable psychological phenomenon known as source monitoring. Whenever we remember something, the brain attempts to identify where the memory originated. Did we personally experience it? Did someone tell us? Did we read about it? Did we imagine it? Most of the time, source monitoring works well. Occasionally it fails. Imagine hearing a joke repeatedly over several years. Eventually you may remember the joke but forget who originally told it. Similarly, people sometimes remember information while forgetting whether it came from a movie, a dream, a conversation, or direct experience. Source confusion may explain many Mandela effects. For example, countless comedians, television programs, and advertisements have quoted Darth Vader saying, "Luke, I am your father." After hearing that version hundreds of times, the altered quote gradually replaces the original memory. The source disappears. Only the memory remains. Modern brain imaging reveals something equally fascinating. Each time a memory is recalled, it temporarily becomes unstable. Neuroscientists call this reconsolidation. During reconsolidation, memories can be modified before being stored again. In effect, remembering something creates an opportunity to change it. This process helps the brain update information efficiently. Unfortunately, it also introduces opportunities for error. Imagine making a photocopy, then photocopying the copy, then copying the next copy. Tiny imperfections accumulate with every generation. Memory behaves similarly. Each recollection subtly edits the next. One of the most surprising discoveries in neuroscience is that forgetting itself is beneficial. At first, this seems counterintuitive. Wouldn't perfect memory be ideal? Not necessarily. Imagine remembering every conversation, every face, every parking space, every meal, every advertisement. The brain would quickly become overwhelmed. Instead, it selectively preserves information most likely to prove useful. Forgetting allows learning, generalization, creativity, decision-making. An imperfect memory system may actually be the most efficient one. This raises an intriguing possibility. Perhaps the Mandela effect is not evidence that memory is failing. Perhaps it is evidence that memory is functioning exactly as evolution intended. Flexible, adaptive, pattern-based, usually reliable, but occasionally producing remarkably convincing illusions. Many psychologists consider this the most likely explanation. Yet not everyone agrees. Critics argue that conventional memory research explains individual mistakes, but struggles to explain why millions remember exactly the same altered details. Could coincidence alone account for such consistency? Or does the Mandela effect hint at something deeper? This question leads us away from psychology and toward one of the most extraordinary ideas in modern physics: the possibility that reality itself may be far stranger than our everyday experience suggests. Parallel universes, alternate timelines, quantum mechanics, and the astonishing proposal that countless versions of reality may exist simultaneously. Whether these ideas explain the Mandela effect remains uncertain, but they have become some of the most fascinating and controversial theories ever proposed. Part 4. What if every decision you have ever made created another version of reality? In one universe, you accepted a particular job. In another, you turned it down. In one, you moved to a different city. In another, you stayed where you were. In one, history unfolded exactly as we remember it. In another, it took a slightly different path. At first glance, the idea sounds like pure science fiction. Yet one of the most discussed interpretations of quantum mechanics suggests something surprisingly similar. It is known as the many worlds interpretation. Although it remains an interpretation rather than an experimentally confirmed fact, it has become one of the most influential and controversial ideas in modern physics. To understand why it fascinates so many people, we first need to explore the strange world of quantum mechanics. During the early 20th century, physicists discovered that nature behaves very differently at the smallest scales. Electrons did not orbit atoms like miniature planets. Light sometimes behaved like a wave, sometimes like a particle. Matter itself displayed wave-like properties. Probability seemed to replace certainty. One of the most famous experiments illustrating this mystery is the double-slit experiment. Imagine a wall containing two narrow openings. Behind the wall is a screen capable of recording tiny impacts. If small objects like marbles are fired toward the wall, they pass through one slit or the other, producing two distinct clusters on the screen. Simple enough. Now repeat the experiment using light. One might expect similar results. Instead, something astonishing happens. Light passing through both slits produces an interference pattern, a pattern characteristic of waves. It appears as though each photon somehow passes through both openings simultaneously and interferes with itself. The mystery deepens further. When scientists attempt to determine which slit each photon actually travels through, the interference pattern disappears. Instead, the photons behave like ordinary particles. Exactly why this happens remains one of the deepest questions in quantum physics. Several interpretations attempt to explain the phenomenon. The traditional Copenhagen interpretation proposes that quantum systems exist as probabilities until measured. Measurement causes one outcome to become reality. Another interpretation, proposed by physicist Hugh Everett III in 1957, suggests something very different. Perhaps the wave function never collapses. Instead, every possible outcome actually occurs. Reality simply branches. In one branch, the photon travels through the left slit. In another, it passes through the right. Observers become part of the branching process as well. Each version experiences only one outcome, unaware that countless alternatives also exist. This became known as the many worlds interpretation. It does not suggest alternate universes floating somewhere in space. Rather, it proposes that reality continuously divides into countless parallel histories. The mathematics behind the interpretation is sophisticated. Yet whether it accurately describes nature remains an open question. Importantly, no experiment has yet confirmed that these branching universes physically exist. Many physicists find the interpretation elegant. Others consider it unnecessarily extravagant. The debate continues today. Once this idea entered popular culture, however, imagination quickly took over. If countless versions of reality exist, could they somehow interact? Could information occasionally cross between them? Could memories leak from one universe into another? These questions captivated writers, filmmakers, and eventually internet communities discussing the Mandela Effect. Some proposed that shared false memories were not false at all. Perhaps they originated in neighboring timelines. According to this theory, millions of people remember the Berenstain Bears because they once existed in another branch of reality. Perhaps Darth Vader really did say, "Luke, I am your father somewhere else." Perhaps history shifted. Perhaps consciousness retained fragments from an alternate universe. It is an imaginative and compelling idea. Unfortunately, there is no experimental evidence supporting it. The many worlds interpretation does not predict memories transferring between branches. Nor does it suggest that universes merge or exchange information after they diverge. In the mathematics, each branch evolves independently. Still, once an idea captures public imagination, it often grows far beyond its scientific origins. The Mandela Effect became fertile ground for increasingly elaborate theories. Some people suggested that reality occasionally resets. Others believed timelines naturally drift together. Some imagined cosmic events causing neighboring universes to overlap briefly. These concepts have appeared in countless novels, television series, and films. Science fiction thrives on such possibilities. Modern physics, however, requires evidence. And thus far, none has been found. Another concept frequently associated with the Mandela Effect involves parallel universes of a different kind. Cosmologists studying the early universe developed a theory known as cosmic inflation. According to inflationary cosmology, the universe expanded at an astonishing rate during the first tiny fraction of a second after the Big Bang. Some versions of this theory suggest that inflation may continue indefinitely in distant regions of space. As a result, countless bubble universes could exist. Each bubble might possess different physical properties, different histories, possibly even different laws of physics. This idea is sometimes called the multiverse. Unlike the many worlds interpretation, which arises from quantum mechanics, inflationary multiverse theories emerge from cosmology. Although mathematically plausible, they also remain unconfirmed. No telescope has observed another universe. No spacecraft has visited one. The multiverse remains an intriguing scientific hypothesis rather than established fact. Nevertheless, popular discussions often blur these distinctions. Many worlds, parallel universes, alternate dimensions, timeline shifts. These different concepts become treated as though they describe the same thing. In reality, they arise from very different areas of physics. Another theory frequently enters Mandela Effect discussions: string theory. Unlike the Standard Model, which treats elementary particles as point-like objects, string theory proposes that the fundamental constituents of nature are unimaginably tiny vibrating strings. Different vibrations produce different particles. To function mathematically, string theory generally requires additional spatial dimensions beyond the familiar three. These hidden dimensions have inspired endless speculation. Some imagine them as hidden worlds existing beside our own. Others picture invisible realms occupied by alternate civilizations. In truth, the extra dimensions proposed by string theory would likely be curled up at scales far smaller than atoms. They are mathematical features of the theory, not giant hidden landscapes waiting to be explored. Yet once again, science fiction embraced the idea. Books, movies, video games. Soon, discussions about extra dimensions naturally became linked with the Mandela Effect. Perhaps altered memories originated from neighboring dimensions. Perhaps realities occasionally overlapped. Perhaps consciousness could somehow access them. These possibilities remain entirely speculative. No experiment has demonstrated communication between dimensions. No evidence suggests memories crossing from one universe to another. Still, the theories persist because they satisfy a deeply human desire. They provide an explanation that feels grand. If reality itself has changed, then mistaken memories become understandable. The brain is no longer at fault. History is. This explanation can feel emotionally satisfying, especially when memories seem exceptionally vivid. Yet science has repeatedly shown that vividness alone does not guarantee accuracy. The human brain is capable of producing memories so convincing that even experts can be fooled. This brings us to another important question. If physics does not currently support timeline shifts, why do so many people connect the Mandela Effect with one particular scientific institution? a laboratory buried beneath the countryside near Geneva. A place where protons race around a 27-kilometer ring at nearly the speed of light. A place known throughout the world simply as CERN. Over the years, countless theories have claimed that CERN's experiments somehow altered reality itself. Some suggest the Large Hadron Collider shifted humanity into another timeline. Others believe particle collisions opened microscopic portals between universes. How did one of the world's leading scientific laboratories become linked to shared false memories? To answer that question, we must examine one of the most enduring and controversial chapters in the Mandela Effect story. The connection between CERN, quantum physics, and the belief that reality itself may have changed. Part 5. By the early 2010s, the Mandela Effect had grown from an obscure internet discussion into a worldwide phenomenon. Forums devoted entirely to shared memories appeared online. Thousands of videos examined logos, movie quotes, maps, and historical events. Every week seemed to bring another alleged example. Then, almost unexpectedly, another topic became woven into the conversation. CERN. To many people, the connection seemed obvious. CERN operated the world's most powerful particle accelerator. Scientists there spoke openly about quantum mechanics. They discussed extra dimensions, dark matter, the Higgs boson, the earliest moments after the Big Bang. For those unfamiliar with particle physics, the language itself sounded mysterious. If any place could accidentally alter reality, surely it would be CERN. But how did that idea actually begin? Part of the answer lies in timing. The Large Hadron Collider officially began operating in 2008. The phrase Mandela Effect entered public discussion in 2009. Within only a few years, social media exploded with examples of shared false memories. For some observers, the sequence appeared suspicious. The collider turns on. Reality begins changing. People remember different histories. Could there be a connection? From a scientific standpoint, timing alone does not establish causation. Many unrelated events happen around the same period. Still, once the idea appeared online, it spread with remarkable speed. One of the first claims suggested that CERN's particle collisions had somehow altered the fabric of spacetime. The phrase itself sounds dramatic. Interestingly, physicists really do use the expression the fabric of spacetime. However, they use it as a metaphor. Einstein's general theory of relativity describes gravity not as an invisible force pulling objects together, but as the curvature of space and time caused by mass and energy. Massive objects such as planets and stars bend spacetime. Smaller objects move along those curves. When physicists discuss the fabric of spacetime, they are describing this mathematical geometry. It is not a literal fabric that can easily be torn open. Yet outside scientific circles, the phrase often took on a much more literal meaning. If spacetime is a fabric, perhaps powerful particle collisions could rip it. Perhaps tiny tears might connect neighboring universes. Perhaps reality itself could be altered. These ideas quickly became popular online. Another frequently misunderstood concept involved the Big Bang. Scientists often explain that the Large Hadron Collider recreates conditions similar to those existing shortly after the universe began. This statement is true, but only in a very limited sense. Inside the collider, particles briefly reach extremely high energies. For unimaginably tiny fractions of a second, conditions resemble those present shortly after the Big Bang. That allows physicists to study how fundamental particles behave under extreme circumstances. It does not mean CERN recreates the Big Bang itself. Nor does it mean miniature universes are being produced beneath Switzerland. The total amount of energy involved in each collision is tiny. What makes the collisions remarkable is not their overall energy, but how intensely that energy is concentrated into an incredibly small region. Unfortunately, this important distinction often disappeared in online discussions. Headlines claiming scientists recreate the Big Bang proved irresistible. Once again, imagination filled the gaps. Another idea frequently mentioned involved black holes. When the Large Hadron Collider was preparing to begin operations, several newspapers published alarming headlines asking whether the machine might accidentally create a black hole capable of swallowing Earth. The story spread rapidly. Some people became genuinely frightened. Lawsuits were even filed in an attempt to stop the collider from operating. Physicists responded calmly. Yes, some speculative theories suggested microscopic black holes might briefly form during extremely energetic collisions. If they existed at all, however, they would be unimaginably tiny. Current theoretical models indicated they would evaporate almost instantly through a process known as Hawking radiation. More importantly, nature has already performed far more energetic collisions for billions of years. Cosmic rays, high-energy particles arriving from deep space, regularly strike Earth's atmosphere with energies exceeding those produced inside the Large Hadron Collider. They also strike the Moon, Mars, Jupiter, the Sun, every planet in the solar system. If dangerous black holes resulted from such collisions, the Earth would not still be here. Nature has conducted the experiment countless trillions of times. The universe remains intact. For most physicists, this observation settled the question. Yet online speculation continued. Some theorists proposed that CERN had not created dangerous black holes, but harmless portals. The argument usually followed a familiar pattern. Black holes distort spacetime. CERN studies extreme energies. Therefore, perhaps microscopic distortions connected neighboring dimensions. No experimental evidence supports this conclusion. Still, it became one of the most frequently repeated claims associated with the Mandela Effect. Around the same time, another event attracted enormous attention. Outside CERN stands a bronze statue of the Hindu deity Shiva in the form of Nataraja, the lord of the cosmic dance. The statue had been presented by the Government of India in recognition of international scientific cooperation. Within Hindu philosophy, Shiva's cosmic dance symbolizes the continual cycle of creation, preservation, and transformation that characterizes the universe. Many physicists appreciated the symbolism. Modern particle physics likewise reveals a universe in constant motion. Particles appear and disappear. Energy transforms into matter. Matter transforms back into energy. To scientists, the statue represented the beauty of cosmic change. To conspiracy theorists, however, it appeared deeply suspicious. Online videos began claiming CERN had deliberately installed a god of destruction because researchers intended to destroy reality itself. This interpretation overlooked an important cultural distinction. In Hindu philosophy, destruction is inseparable from renewal. It represents transformation rather than simple annihilation. Nevertheless, the image became another piece of supposed evidence. Then came the incident that perhaps did more than anything else to fuel conspiracy theories. In 2016, security cameras recorded several individuals entering CERN's grounds after hours. The footage appeared to show a mock ritual taking place near the Shiva statue. One participant seemed to stab another while several others watched. When the video appeared online, millions viewed it. Some immediately concluded they had witnessed an occult ceremony inside one of the world's leading scientific laboratories. CERN investigated. The explanation proved considerably less dramatic. The participants were believed to be employees or visiting researchers staging an unauthorized prank. No one had been harmed. The apparent victim was acting. The organization condemned the incident because it violated security rules. For many viewers, however, the official explanation changed nothing. Some argued it was a cover-up. Others claimed the ritual had been genuine. This illustrates a common feature of conspiracy theories. Once people become convinced that authorities are hiding the truth, every denial becomes additional evidence of deception. The theory becomes difficult, sometimes impossible, to disprove. Another curious event involved a light-hearted employee video celebrating the restart of the Large Hadron Collider after maintenance. Researchers danced through hallways carrying humorous signs. One briefly displayed the word Mandela. Internet investigators immediately noticed. Was this a secret confession? An inside joke? A hidden message? Viewed in context, the video resembled countless playful workplace productions. Yet once viewers expected hidden meanings, every detail appeared significant. Psychologists refer to this tendency as apophenia. The human brain evolved to recognize patterns. It is exceptionally good at connecting scattered pieces of information. Most of the time, this ability helps us survive. Occasionally, it encourages us to perceive meaningful relationships where none actually exist. The same psychological process allows people to see faces in clouds, animals in rock formations, or hidden codes in random numbers. Pattern recognition is one of humanity's greatest strengths. It can also become one of our greatest sources of error. This brings us to another important point. The language of modern physics is often deeply unintuitive. Physicists speak of quantum fields filling empty space, virtual particles appearing from the vacuum, extra dimensions, wave functions, probability amplitudes. To specialists, these terms possess precise mathematical meanings. To the general public, they can sound almost mystical. This gap between scientific language and everyday understanding created fertile ground for misunderstanding. As internet videos grew more sophisticated, many began blending genuine scientific concepts with unsupported speculation. Quantum mechanics became intertwined with alternate realities. Particle collisions became portals. The Higgs boson became the God particle. The result was a compelling narrative. One that was exciting, mysterious, and often far removed from what the science actually demonstrated. Still, one question remained. If CERN probably wasn't responsible for the Mandela Effect, why did the idea resonate so strongly with millions of people? The answer may lie in something even more intriguing than particle physics: the remarkable way the human mind searches for meaning, even when certainty remains just beyond its reach. Part 6. If there is one thing the Mandela Effect reveals more clearly than almost any other phenomenon, it is that the human brain desperately wants the world to make sense. Our minds are extraordinary pattern recognition machines. Long before civilization existed, this ability helped our ancestors survive. A rustling sound in tall grass might indicate nothing more than the wind, or it might signal the approach of a predator. The individuals who noticed patterns quickly were more likely to survive. Over thousands of generations, natural selection favored brains that constantly searched for connections. Even today, that instinct remains deeply embedded within us. We naturally look for causes. We search for explanations. When two unusual events happen close together, we instinctively wonder whether they are related. Most of the time, this instinct serves us well. Sometimes, however, it leads us astray. Psychologists have a name for one of these tendencies: apophenia. Apophenia is the tendency to perceive meaningful relationships between unrelated things. It is remarkably common. Look at the clouds. You may see dragons, faces, ships, animals. The clouds have not intentionally formed those images. Your brain has assembled familiar patterns from random shapes. The same thing happens when people notice familiar figures in the surface of the moon, or religious images appearing in toast, or hidden messages inside random sounds played backward. The brain constantly searches for order. Closely related is another phenomenon known as pareidolia. Pareidolia specifically involves recognizing familiar images, especially faces, where none actually exist. It explains why electrical outlets often appear to have expressions, why the front of a car sometimes seems to be smiling, why rocks occasionally resemble human profiles. Humans are exceptionally skilled at recognizing faces. So skilled, in fact, that we often find them where they do not exist. The Mandela Effect may represent a similar process operating not with vision, but with memory. Our brains organize countless fragments of information into coherent stories. Occasionally, they organize those fragments incorrectly. Another fascinating psychological principle is confirmation bias. Imagine that someone tells you red cars are involved in unusually high numbers of traffic accidents. The next time you drive, you begin noticing every accident involving a red vehicle. Accidents involving blue or silver cars fade into the background. Soon it seems as though red cars truly are involved in most collisions. Your attention has become selective. Confirmation bias works in much the same way. Once people become convinced that reality has changed, they begin noticing every example supporting that belief. Examples contradicting it often receive far less attention. This does not happen intentionally. The brain naturally favors information reinforcing existing expectations. Scientists are not immune to confirmation bias. Neither are judges, doctors, engineers, teachers, or historians. Recognizing this tendency is one reason science relies upon controlled experiments rather than personal impressions alone. Another remarkable feature of human thinking involves social reinforcement. Suppose you vaguely remember something from childhood. You are uncertain. Then you discover thousands of people online describing exactly the same memory. Your confidence immediately increases. After all, how could so many people be wrong? Psychologists call this social validation. When others share our beliefs, those beliefs feel stronger. The internet has amplified this process dramatically. Before social media, someone with an unusual memory might never meet another person sharing it. Today, a single online post can reach millions within hours. Entire communities form around shared recollections. Members compare experiences, encourage one another, strengthen each other's confidence. The more often a memory is discussed, the more convincing it may become. This process does not require deception. It occurs naturally whenever groups exchange information. The internet has simply accelerated it to an unprecedented degree. Another intriguing concept is collective memory. Every society develops shared memories about important events. These memories are influenced by schools, television, movies, newspapers, family conversations, public commemorations. Over time, details become simplified. Complicated events evolve into memorable stories. Sometimes those stories differ slightly from historical reality. Consider famous quotations. Many historical figures never actually spoke the words attributed to them. Marie Antoinette almost certainly never said, "Let them eat cake." Sherlock Holmes never declared, "Elementary, my dear Watson." The phrase evolved gradually through later adaptations. Even Captain Kirk's famous command, "Beam me up, Scotty," never appeared exactly that way in the original Star Trek television series. Yet millions remember these quotations because they capture the essence of the characters. The simplified versions become culturally stronger than the originals. This process illustrates how collective memory evolves. The Mandela Effect may represent an extension of this phenomenon. Not history changing, but culture reshaping memory. Still, some reported experiences extend beyond logos and movie quotes. Many people describe what they call reality glitches. Perhaps an object disappears from a table only to reappear days later in exactly the place already searched multiple times. Others report clocks behaving strangely. Some describe entering familiar buildings that briefly seem unfamiliar. Still others insist they have experienced moments when reality itself felt subtly different. These stories have existed for generations. Long before the internet, people spoke of mysterious disappearances, time slips, and unexplained coincidences. Today, such accounts are often grouped together with the Mandela Effect. Psychologists suggest several possible explanations. Attention is selective. We frequently overlook objects directly in front of us. Anyone who has searched frantically for a pair of glasses only to discover them resting on top of their head understands this perfectly. The brain filters enormous amounts of sensory information. Occasionally, important details escape notice. Memory then fills the gaps. Coincidences also play a significant role. Every day, billions of people experience countless events. Given such enormous numbers, highly unusual coincidences become inevitable. Most pass unnoticed. A few seem astonishing. When they happen to us personally, they often feel deeply meaningful. This tendency is known as the clustering illusion. Random events naturally form clusters. The human brain interprets those clusters as patterns. Another topic frequently linked with the Mandela Effect is déjà vu. Nearly everyone has experienced it. You enter a room. Hear a conversation. Meet someone new. Suddenly you feel absolutely certain that the moment has happened before. The sensation can be remarkably convincing. For centuries, déjà vu has inspired speculation. Some believed it represented memories from previous lives. Others suggested glimpses of the future. Still others proposed parallel universes. Modern neuroscience offers a less mysterious explanation. Research suggests déjà vu may result from a brief mismatch between brain systems responsible for familiarity and conscious recollection. The brain incorrectly labels a new experience as familiar. The sensation feels profound because it originates within the mechanisms normally used to recognize genuine memories. Again, the experience itself is real. Its interpretation remains uncertain. Dreams provide another fascinating example. Many people report dreaming about events that later seem to occur. Usually, careful examination reveals subtle differences. The dream resembles reality without matching it exactly. Considering that most people dream several times every night, occasional similarities become statistically inevitable. Yet emotionally, such experiences often feel extraordinary. The Mandela Effect thrives in the space between certainty and uncertainty. Between memory and perception. Between coincidence and meaning. Perhaps this explains why the phenomenon has become so enduring. It touches experiences nearly everyone has had. Forgetting names. Misremembering conversations. Feeling déjà vu. Searching for missing objects. Recalling movie quotes incorrectly. These experiences are familiar. The Mandela Effect simply gathers them into a larger narrative. A narrative suggesting that something much bigger may be happening. Whether that narrative reflects psychology, physics, or something else entirely, remains one of the central questions of the phenomenon. There is, however, another theory that has captured public imagination almost as powerfully as parallel universes. Unlike alternate timelines, this idea suggests that reality has not shifted at all. Instead, reality itself may never have been real in the first place. The possibility that our entire universe is an unimaginably sophisticated simulation, and that the Mandela Effect might represent nothing more than tiny glitches in the system. Part 7. Imagine sitting down to play a highly advanced virtual reality game. The graphics are perfect. The world stretches endlessly in every direction. Every tree moves naturally in the wind. Every person appears completely real. Every sound, every shadow, every tiny detail behaves exactly as it should. Now imagine that the simulation becomes so advanced that the characters inside it become self-aware. They begin asking questions. Who created this world? Why do the laws of nature behave the way they do? What exists beyond the visible horizon? Could they ever discover they were living inside a simulation? For thousands of years, philosophers have asked similar questions. Long before computers existed, thinkers wondered whether reality might be an illusion. Around 380 BC, the Greek philosopher Plato described his famous allegory of the cave. In the story, prisoners spend their entire lives chained inside a cave. They see only shadows cast upon a wall. Having never experienced the outside world, they believe the shadows are reality itself. Only when one prisoner escapes does he discover that everything he believed was merely a reflection of something greater. More than 2,000 years later, French philosopher René Descartes proposed another thought experiment. How could anyone prove that reality was genuine? What if an all-powerful deceiver manipulated every sensation, every sight, every sound, every memory? Could we ever know the difference? These philosophical puzzles remained largely theoretical until the computer age. As technology advanced, virtual worlds became increasingly realistic. Video games evolved from simple moving dots into breathtaking digital environments. Artificial intelligence began creating convincing conversations. Virtual reality headsets immersed users in computer-generated landscapes. The boundary between simulation and reality seemed less obvious than ever before. Then, in 2003, philosopher Nick Bostrom introduced an argument that would become one of the most discussed ideas of the 21st century. It became known as the simulation hypothesis. Bostrom did not claim that we definitely live inside a simulation. Instead, he proposed a logical argument based on probability. His reasoning began with three possibilities. First, perhaps civilizations usually destroy themselves before developing the technology needed to simulate conscious beings. Second, perhaps advanced civilizations simply choose not to create such simulations. Third, if advanced civilizations survive and create enormous numbers of simulated worlds, then simulated realities could vastly outnumber original ones. If that were true, statistically speaking, conscious beings would be more likely to find themselves inside a simulation than in the original universe. It is an elegant philosophical argument. Notice, however, what it does not provide. Evidence. The simulation hypothesis remains exactly that. A hypothesis. It is an idea intended to stimulate discussion rather than an experimentally confirmed scientific theory. Nevertheless, it captured public imagination almost immediately. Movies such as The Matrix had already introduced similar concepts to millions of viewers. In that fictional world, humanity unknowingly lived inside an artificial computer simulation while their bodies remained connected to machines. The story became one of the most influential science fiction films ever made. Soon, discussions about the Mandela Effect naturally merged with simulation theory. Suppose reality truly is a simulation. What might happen if the software were updated? Could tiny details change? Could company logos be modified? Movie dialogue corrected? Maps adjusted? Would some people somehow remember the previous version? These questions fascinated internet communities. The Mandela Effect became interpreted not as faulty memory, but as evidence of software updates. Some even referred to the phenomenon as reality patches. Others suggested humanity occasionally noticed programming errors, glitches, bugs, small inconsistencies revealing the artificial nature of existence. Again, the idea makes compelling fiction. But does any scientific evidence support it? At present, the answer is no. No experiment has detected computer code embedded within reality. No hidden pixels have appeared under powerful microscopes. No mathematical proof demonstrates that the universe is running on an unimaginably advanced computer. Still, some physicists have explored whether certain experiments might one day test aspects of the simulation hypothesis. For example, if space itself possessed the smallest possible resolution, analogous to pixels on a computer screen, it might leave subtle signatures detectable by extremely sensitive instruments. Thus far, no such evidence has been confirmed. The universe continues behaving according to known physical laws. That has not stopped speculation. Another frequently discussed possibility involves computational limits. Modern video games often simplify distant scenery to conserve processing power. Perhaps, some argue, the universe does something similar. Maybe quantum uncertainty exists because reality renders details only when necessary. This comparison is imaginative. Interestingly, it also illustrates a misunderstanding. Quantum mechanics does not suggest the universe loads reality only when someone observes it. Rather, it describes probabilities governed by precise mathematical equations. The uncertainty lies within the measurements themselves, not necessarily because the universe lacks sufficient computing power. Nevertheless, the analogy remains popular because it feels intuitive to people familiar with modern technology. Another subject often connected with simulation theory is the concept of glitches. Have you ever walked into a room and momentarily forgotten why? Misplaced an object only to find it exactly where you already searched? Experience déjà vu? Some internet discussions interpret these everyday experiences as evidence that reality briefly malfunctioned. Psychologists generally disagree. Attention is selective. Memory is reconstructive. Perception is imperfect. These ordinary characteristics of the human brain explain many such experiences without requiring computer simulations. Yet there remains something undeniably fascinating about the idea. Modern civilization increasingly creates artificial worlds. Virtual reality. Augmented reality. Artificial intelligence. Digital twins. Entire cities can now be simulated with astonishing accuracy. If technology continues advancing for centuries or millennia, the possibility of creating conscious simulations becomes less obviously impossible. Whether such civilizations would actually do so remains another question entirely. One intriguing aspect of the simulation hypothesis is that it cannot easily be disproven. Suppose someone claims that every piece of evidence against the theory has itself been simulated. How could such a claim ever be tested? This illustrates an important principle in science. A useful scientific theory must make predictions that can, in principle, be proven wrong. If no possible observation could ever disprove an idea, that idea belongs more naturally to philosophy than experimental science. Simulation theory currently occupies that philosophical territory. It encourages deep thinking about consciousness, reality, and existence. It does not yet provide experimentally testable predictions capable of confirming or rejecting it. Still, many people continue connecting simulation theory with the Mandela Effect because it offers an explanation that feels comprehensive. Shared false memories become software remnants. Reality glitches become programming errors. Unexpected coincidences become evidence of hidden algorithms. Whether true or not, the theory satisfies our desire for a larger narrative. One in which the strange experiences many people report become meaningful pieces of a much greater mystery. Yet another possibility exists. Perhaps neither faulty memory, nor parallel universes, nor computer simulations fully explain the Mandela Effect. Perhaps the answer lies somewhere between psychology and physics, within the strange and often misunderstood world of quantum mechanics itself. The next chapter explores quantum theory, hidden dimensions, and why one of the most successful scientific theories ever developed has become so closely associated with one of the Internet's greatest mysteries. Part 8. Few scientific subjects have been misunderstood more than quantum mechanics. Mention the word quantum in a conversation, and people often think of mysterious forces, hidden dimensions, alternate realities, or even supernatural abilities. Movies use quantum physics to explain time travel. Television shows use it to justify parallel universes. Books invoke it to describe psychic phenomena. Internet videos often present quantum mechanics as though it were limitless magic disguised as science. The reality is both less mystical and far more astonishing. Quantum mechanics is one of the most successful scientific theories ever developed. Its predictions have been tested countless times. Modern computers, lasers, semiconductors, MRI machines, LED lighting, solar panels. Every smartphone on Earth depends upon principles derived from quantum physics. Without quantum mechanics, modern civilization would look completely different. Yet despite its extraordinary success, the theory remains deeply unintuitive. At the quantum level, particles behave in ways unlike anything encountered in everyday life. Electrons behave as both particles and waves. Photons can interfere with themselves. Atoms may exist in mathematical states representing multiple possibilities simultaneously. None of this resembles our everyday experience. It is therefore unsurprising that quantum mechanics has become fertile ground for speculation. One of the most misunderstood concepts is the observer effect. Many people have heard the statement, "Observing a particle changes its behavior." This is true. Unfortunately, it is often misunderstood. The phrase does not mean that human consciousness magically creates reality. Instead, observation in physics means interaction. To measure an electron, scientists must interact with it. Perhaps by shining light upon it. Perhaps by detecting another particle that collides with it. That interaction inevitably influences the system being measured. The measuring device, not necessarily a conscious human observer, is part of the experiment. This distinction is crucial. Yet popular culture often omits it. Soon, the observer effect became transformed into a much grander claim. Consciousness creates reality. Books appeared suggesting that human thoughts directly shape the physical universe. Some claimed focused intention could alter quantum events. Others proposed that collective consciousness generated the world around us. The Mandela Effect soon became connected to these ideas. If consciousness creates reality, perhaps millions of people remembering the same thing could actually change history. Perhaps reality adjusts itself according to collective belief. It is certainly an imaginative hypothesis. However, no experimental evidence currently supports this interpretation. Quantum mechanics does not predict that large groups of people can rewrite history through shared memory. Another frequently misunderstood concept is quantum superposition. Before measurement, quantum systems are mathematically described as existing in combinations of possible states. This idea is often illustrated by one of the most famous thought experiments in science: Schrödinger's cat. In 1935, Austrian physicist Erwin Schrödinger proposed a deliberately absurd scenario. Imagine placing a cat inside a sealed box. The cat's survival depends upon a quantum event involving a radioactive atom. If the atom decays, poison is released. If it does not decay, the cat remains alive. According to one interpretation of quantum mechanics, the atom exists in a superposition of possibilities before observation. Schrödinger argued that extending this idea to everyday objects produced absurd conclusions. Would the cat be simultaneously alive and dead? His thought experiment was intended to highlight the conceptual difficulties involved in interpreting quantum theory. It was never meant to suggest that actual cats exist in both states simultaneously in the ordinary sense. Nevertheless, Schrödinger's cat became one of the most recognizable images associated with quantum physics. Popular culture soon transformed the metaphor into something much larger. Perhaps entire realities exist simultaneously. Perhaps history branches continuously. Perhaps the Mandela Effect reflects awareness shifting between quantum possibilities. Again, fascinating. But unsupported by experimental evidence. Another quantum phenomenon frequently associated with the Mandela Effect is entanglement. Albert Einstein famously disliked the idea. He referred to it as spooky action at a distance. When two particles become entangled, measuring one immediately determines the corresponding property of the other, even if they are separated by enormous distances. Experiments have repeatedly confirmed entanglement. It is very real. However, it does not allow information to travel faster than light. Nor does it permit communication across alternate universes. The mathematics governing entanglement is precise. Although deeply counterintuitive, it remains fully consistent with modern physics. Yet internet discussions often extend entanglement far beyond what experiments demonstrate. Some claim human minds become quantum entangled. Others suggest memories remain connected across timelines. Still others argue consciousness itself operates through entanglement. At present, these ideas remain speculative. No experimental evidence demonstrates such effects. Perhaps the most ambitious attempt to connect consciousness with quantum mechanics comes from the theory proposed by physicists Sir Roger Penrose and anesthesiologist Stuart Hameroff. Known as orchestrated objective reduction, or simply orchestro-R, the theory suggests quantum processes occurring inside microscopic structures within brain cells may contribute to conscious experience. The idea remains controversial. Some neuroscientists consider it plausible. Others argue that the warm, noisy environment of the brain would rapidly destroy delicate quantum states. Research continues. Importantly, even if orchestro-R, or another quantum theory of consciousness, proved correct, it would not automatically explain the Mandela Effect. Theories connecting quantum consciousness with alternate timelines remain speculative additions rather than established scientific conclusions. Then there are hidden dimensions. Modern theoretical physics contains several mathematical models requiring more dimensions than the familiar 3 dimensions of space and 1 dimension of time. String theory is perhaps the best known. Some versions require 10 dimensions. Others require 11. These additional dimensions would not resemble hidden worlds existing beside us in the ordinary sense. Instead, they would likely be curled into unimaginably tiny scales beyond direct observation. Still, once people heard that physics proposed extra dimensions, imagination naturally expanded the idea. Perhaps memories occasionally leak between them. Perhaps reality overlaps. Perhaps the Mandela Effect originates there. No evidence currently supports these conclusions. The hidden dimensions of string theory remain mathematical constructs rather than experimentally verified locations. Interestingly, many physicists welcome these speculative discussions, even when they disagree with the conclusions. Why? Because curiosity drives science. Many revolutionary discoveries began as bold ideas. Black holes were once purely mathematical predictions. Gravitational waves remained theoretical for a century before being detected. The Higgs boson existed only in equations for nearly 50 years before experiments confirmed it. The difference lies in evidence. Each successful theory eventually produced measurable predictions. Experiments either confirmed or rejected them. That process distinguishes science from speculation. Speculation imagines possibilities. Science tests them. The Mandela Effect occupies an unusual position because it sits at the intersection of psychology, philosophy, neuroscience, and physics. Each field contributes part of the discussion. None currently provides a complete explanation satisfying everyone. This uncertainty explains why the mystery continues attracting attention. When science openly admits that certain questions remain unanswered, imagination naturally begins exploring possibilities. Some possibilities eventually become accepted discoveries. Others quietly disappear. Many remain fascinating thought experiments. As the Mandela Effect continued spreading across the internet, another factor began shaping the conversation. Not quantum mechanics. Not neuroscience. But something far more familiar. The internet itself. Social media. Algorithms. Online communities. Together, they transformed a relatively obscure observation into one of the most recognizable mysteries of the digital age. Part 9. Long before the internet existed, people occasionally disagreed about their memories. Friends argued over song lyrics. Families debated the wording of old advertisements. Someone insisted a movie ended one way, while someone else remembered something entirely different. Most of these conversations ended quickly. Someone found a newspaper clipping. A videotape. A book. The disagreement was settled. The discussion moved on. Today, the situation is very different. The internet has fundamentally changed the way human beings share information and the way we remember it. Imagine someone discovers that the Monopoly man never wore a monocle. They post the observation online. Within minutes, thousands of people from different countries respond. I remember the monocle too. I thought I was the only one. I've believed that my entire life. Very quickly, what began as an isolated observation becomes a global conversation. The internet has connected billions of human memories. For the first time in history, people can instantly compare recollections with strangers across the world. This alone transformed the Mandela Effect from a curious psychological phenomenon into an international cultural mystery. Social media accelerated the process even further. Platforms reward content that surprises people. Content that creates emotional reactions. Content that encourages sharing. Few topics accomplish that better than the Mandela Effect. A simple headline. Everything you remember about this movie is wrong. Almost demands attention. People immediately check their own memories. They send the article to friends. Arguments begin. Discussions spread. Algorithms recognize the engagement. The content reaches even larger audiences. Before long, millions of people have encountered the same example. This creates a fascinating feedback loop. The more people discuss a particular Mandela effect, the stronger that shared memory appears to become. Repeated exposure reinforces confidence. Psychologists have long understood another phenomenon known as the illusory truth effect. The principle is remarkably simple. The more often people hear a statement, the more likely they are to believe it, even when the statement is false. Repetition creates familiarity. Familiarity often feels like truth. Advertising has relied upon this principle for decades. Political campaigns use it. News organizations must constantly guard against it. The Mandela Effect benefits from the same psychological tendency. Suppose someone repeatedly hears that Curious George once had a tail. After enough repetitions, even people who had never previously considered the question may begin believing they remember one. Not because they are gullible. Because the human brain naturally equates familiarity with accuracy. This is one reason researchers are careful when discussing memory. Simply describing a false memory can sometimes increase the likelihood that someone later believes it. Another important factor is nostalgia. Many Mandela effects involve childhood experiences. Children's books. Classic cartoons. Family board games. Old television shows. Why? Because childhood memories are often emotional. Emotion strengthens memory. At the same time, decades may have passed since those memories were formed. Small inaccuracies accumulate over time. When people revisit beloved childhood experiences, even tiny differences can feel deeply significant. It is not simply a logo that appears different. It feels as though a small piece of childhood has changed. That emotional response helps explain why the Mandela effect resonates so strongly. It touches identity. Memory forms part of who we are. If our memories become uncertain, part of our personal history feels uncertain as well. The internet has also created something sociologists call participatory culture. People no longer consume information passively. They contribute, comment, debate, create videos, analyze evidence, build communities. The Mandela Effect became an ideal subject for this collaborative investigation. Thousands of individuals searched old newspapers, collected vintage advertisements, compared first edition books, examined historical maps, analyzed movie scripts frame by frame. In many cases, these investigations confirmed that current records had always been consistent. Yet the shared memories remained. This persistence is one reason the phenomenon continues to fascinate psychologists. The internet has also blurred the distinction between expertise and popularity. A professionally researched scientific explanation may receive modest attention. A dramatic video claiming reality has shifted may attract millions of views. Popularity does not necessarily reflect accuracy. It reflects interest. Mystery attracts audiences. Uncertainty generates discussion. Social media platforms naturally amplify such topics. This does not mean the platforms intentionally spread misinformation. Rather, their algorithms reward engagement. Content provoking curiosity, surprise, or debate often spreads farther than careful explanations. This dynamic has shaped public understanding of countless subjects beyond the Mandela Effect. Science, medicine, history, politics. The same psychological mechanisms appear repeatedly. Another interesting feature of online Mandela Effect communities is the development of shared language. Terms such as residue became common. In these communities, residue refers to objects that appear to preserve evidence of an earlier version of reality. For example, someone might discover an old advertisement using the phrase, "Luke, I am your father." Believers argue that such material represents remnants of a previous timeline. Skeptics point out that advertisements, parodies, and merchandise often intentionally altered famous quotations for clarity or humor. Both sides examine the same evidence. They simply interpret it differently. This highlights another important principle. Evidence rarely speaks for itself. Interpretation matters. The same photograph, the same document, the same memory can support very different conclusions depending upon the assumptions brought to it. Scientists attempt to minimize this problem through controlled experiments and independent verification. Even then, interpretation remains an important part of research. The Mandela Effect also illustrates the power of storytelling. Human beings understand the world through narratives. A collection of unrelated memory errors feels uninteresting. A story involving parallel universes, quantum physics, and altered timelines feels compelling. Stories help organize information. They provide meaning. They satisfy our desire for coherent explanations. Sometimes those stories prove accurate. Sometimes they do not. The challenge lies in distinguishing evidence from narrative. Despite years of investigation, no single explanation accounts for every reported Mandela Effect. Psychology explains many examples remarkably well. Neuroscience reveals how memory changes over time. Social science demonstrates the influence of collective discussion. Physics offers fascinating theoretical possibilities, though none currently provide experimental support for shifting timelines or merging realities. Perhaps the greatest lesson is one of humility. Human memory is extraordinarily powerful. Yet it is not perfect. Science is remarkably successful. Yet it does not possess every answer. Curiosity drives discovery. Skepticism protects us from jumping to conclusions. Both qualities are essential. The Mandela Effect continues because it exists precisely at the intersection of these two human traits: wonder and doubt. That leaves one final question. After exploring psychology, neuroscience, quantum theory, simulation hypotheses, parallel universes, CERN, and the Internet, what can we honestly conclude? Is the Mandela Effect simply a fascinating feature of human memory? Or does it hint at mysteries science has yet to uncover? The final chapter brings together everything we have explored and asks perhaps the most important question of all. What should we believe when our memories disagree with reality? Part 10. Imagine that two people stand before the same painting. One sees only colors applied to a canvas. The other sees emotion, history, technique, symbolism. Neither person is necessarily wrong. They are simply looking through different lenses. The Mandela Effect invites us to do something similar. It asks us to examine one of the most familiar parts of our lives, memory, and consider the possibility that it may be more complex than we ever imagined. Throughout this journey, we have explored an extraordinary range of ideas. We began with Fiona Broom's observation that many people remembered Nelson Mandela dying in prison decades before he actually passed away. From there, we encountered famous examples involving children's books, movie quotes, logos, geography, and popular culture. We examined the remarkable flexibility of human memory. We discovered that memories are not replayed like recordings but reconstructed each time they are recalled. Psychologists demonstrated that false memories can be created surprisingly easily. Neuroscientists showed that recollection itself changes memory. Social scientists revealed how groups influence one another's confidence. The internet transformed isolated observations into global conversations. Each field contributed valuable insight. Yet none completely eliminated the mystery. For many people, conventional psychology explains the Mandela Effect well enough. The brain simplifies information. It searches for familiar patterns. It unconsciously fills gaps. Over time, shared culture encourages similar mistakes. From this perspective, the Mandela Effect is not evidence that reality has changed. It is evidence that human memory works remarkably well most of the time, and occasionally in surprisingly predictable ways. Others remain unconvinced. They point to the emotional certainty associated with many memories. They ask why millions of unrelated people often remember the same incorrect details. They wonder whether existing psychological explanations are sufficient. Some look toward quantum mechanics. Others consider the many worlds interpretation. Some explore the possibility of parallel universes. Others find simulation theory compelling. At present, none of these ideas has been confirmed as an explanation for the Mandela Effect. They remain speculative, interesting, thought-provoking, but unproven. This distinction matters. Science progresses through evidence, not popularity, not intuition, not certainty alone. History reminds us that sincere conviction is not always reliable. People have sincerely believed many things later shown to be incorrect. At the same time, history also teaches another lesson. Ideas once dismissed as impossible have sometimes become accepted science. Continents really do drift across Earth's surface. Invisible bacteria really do cause disease. Space and time really are linked together. Gravitational waves really do ripple across the universe. Scientific progress often begins with unusual questions. The challenge lies in asking those questions responsibly. Curiosity without evidence becomes speculation. Evidence without curiosity leads nowhere. The most productive path combines both. The Mandela Effect offers an opportunity to practice exactly that balance. Consider one final thought experiment. Suppose scientists eventually develop a complete understanding of memory. Every neural connection, every mechanism of recall, every source of error. Would the Mandela Effect disappear? Probably not. Because the phenomenon is about more than memory. It is about human experience. It is about the unsettling feeling that reality and recollection no longer agree. That emotional experience is genuine regardless of its ultimate cause. Someone remembering the Monopoly man with a monocle is not pretending. The memory feels authentic. Understanding why the memory exists does not make the experience any less real. This distinction is important. False memories are not lies. They are sincere recollections shaped by the remarkable way the brain processes information. Recognizing this can encourage humility. If our own memories occasionally prove unreliable, perhaps we should approach disagreements with greater patience. After all, everyone experiences the world through the remarkable, but imperfect, filter of the human mind. The Mandela Effect also reminds us how deeply stories shape civilization. Humans are storytellers by nature. We preserve history through narratives. Teach children through stories. Understand ourselves through memory. When those memories become uncertain, we naturally search for explanations. Sometimes the explanation is psychological. Sometimes historical. Sometimes scientific. Sometimes philosophical. The search itself reflects something profoundly human. Perhaps that is why the Mandela Effect has endured. It exists at the intersection of science, psychology, philosophy, and mystery. It allows people from very different backgrounds to ask the same fundamental questions. What is memory? What is reality? Can we trust our perceptions? How certain can we ever be? These questions are unlikely to disappear. Future neuroscience may explain memory in far greater detail. Artificial intelligence may reveal new insights into cognition. Quantum physics may continue reshaping our understanding of reality. Perhaps one day entirely new discoveries will emerge. Whether those discoveries support current explanations or reveal something unexpected remains impossible to know. Science has surprised humanity many times before. It almost certainly will again. Until then, the Mandela Effect occupies a unique place in modern culture. It is simultaneously a psychological phenomenon, an internet sensation, a philosophical puzzle, and a reminder that certainty is often more fragile than we imagine. Perhaps the greatest lesson is not that reality has changed, nor that alternate universes exist, nor that memory is hopelessly unreliable. Perhaps the greatest lesson is that human understanding is always evolving. Every generation inherits mysteries from the one before it. Some mysteries are solved. Others deepen. Still others inspire entirely new fields of study. The Mandela Effect belongs to that long tradition of questions that encourage us to look more carefully at ourselves and the world around us. Whether the answers ultimately come from psychology, physics, neuroscience, or an entirely unexpected direction, the search itself remains worthwhile. Because every mystery, regardless of its outcome, teaches us something. Sometimes about the universe, sometimes about the mind, and sometimes about the remarkable relationship between the two. Perhaps that is why the Mandela Effect continues to captivate millions of people around the world. Not because it proves that reality has changed, but because it reminds us that reality, and our understanding of it, may be far more fascinating than we ever imagined. As long as human beings continue asking questions, comparing memories, testing ideas, and searching for evidence, the mystery will endure. And somewhere, someone will once again open an old book, watch a familiar movie, look at a well-known logo, and pause for just a moment, wondering whether the world has changed, or whether the greatest mystery has been inside the human mind all along.